All right, guys. In session one, we did quite a lot of trig. In fact, we only did trig. A lot of marks, 40 marks or so. So please use all the ideas that we spoke about. All right, use all the ideas that we spoke about, and let's get all the marks. Don't make mistake. Be very careful. Be thorough through your thoughts. Take your time. There's enough time to finish. We only need to learn how to manage. Okay, so today, I know the other big section that we are all scared of would be Euclidean geometry, right? But guys, I'm not going to do the proofs. You should know the proofs by now. I also sent videos this morning. Was it this morning? Yeah, just, put your earphones in and just watch but don't just watch. If you watch and think, now I know it, you'll be shocked. You need to sit down and write it down. And the thing is, there are 6 of them. You don't know which one of them would be there. So please, let's get those 5 marks even before we go into the exam. One of them will definitely show up. I need to check. I do have, but you should know all the reasons of each of the theorems. But just remind me, I'll check again. Okay. Hi, Dash. I think the more I'm getting better, I'm feeling better. Yeah, feeling better today than other days, but all good. All right. I think for me on Euclidean, what will be very, very pertinent to me right now, very important to me. Okay, before we go to Euclidean, let's touch on analytical. Just pass through quickly, 30 minutes or so. Then we end up with Euclidean, and if there's 1, 2, 3 things to be said on stats, we just say it. Okay, so I'm running through as fast as I can. There are some obvious marks here. Very obvious marks that no one should be throwing away out of carelessness. So be thorough when we look at this. In the diagram below, sketched below, we have AD are points on triangle ABD and ACD. B and C are points on the Y, okay, and they give us 90 degrees. Calculate the coordinate of M, the midpoint. You see, that is an everybody mark, right? How do you calculate midpoint? X1 plus X2 over 2, Y1 plus. It's an that mark is for everybody from grade 10. All right. So we are looking for what? M, midpoint of what? AD. So what do we have? Minus 3 minus 5 over 2. I hope you are going to give me answers quickly. Then 9 plus 1 over 2. Over 2. Answers. Negative 4. Positive 5, right? We're done there. 3.2. 3.2. Okay. Guys, we agree, right? Then you don't waste time. Just get it quickly and move. Number 2. Calculate the length of the radius of the circle passing through ABD. So now they're telling us that there's a circle that passes through ABD. I'm already seeing Euclidean geometry. You know why? Because I see a 90 degrees and there's a circle passing through ABD. I am already seeing a bit of Euclidean. And what are you seeing? I'm already seeing angle at the center, right? Because of that 90 degrees. Okay. So that already is playing a role. And we've already calculated, oh, I see. It now makes sense. We got this point already. What is this point? This point now becomes what? The center of the circle. That's why they're asking us to calculate the length of the radius. Basically, they are asking, you can use midpoint again, calculate the whole AD and divide by what? By 2. So just by drawing that circle alone makes a lot of difference for me. Is that fine? Right. So, what is 3.2? The length of the radius. Is either you calculate distance between M and D or M and A. Please get that for me quickly, everybody. I want the distance, AM. Use your formula, distance formula, square root of, you know the distance formula, right? Square root of what? X2 minus X1 squared plus Y2 minus Y1 squared. Who's done it? Can I have a confirmation to that answer? Oh yeah, thank you, Nilufa. Nilufa confirmed, root 17. So I need us to move as fast as that in the exam. Please don't write these formulas from your head. Use your formula page, because under stress, you'll be writing plus instead of a negative. And you see what I did? They said there's a circle there. What do? Just use a pencil. Create that circle and see what's going on. We are better with visuals than just virtual. Where's your glasses? Forgot them. Okay. Will point C lie on the circle? Give a reason. Okay. Guys, you cannot use my construction to judge. How do you know if a point lies in the circle? When I did analytical geometry, I did this. Let me quickly explain. If I have a circle here and I have a dot, there are possible 3 points. 1, 2, right? What do you notice? B is the radius of the OB is the radius of the circle, right? Good. So if OA, what do we know about OA? OA should be less than what? The radius. So any point less than the radius would be in the circle. OB is equal to R. So this would be what? On the circle. The distance OC is definitely greater than R. So it should be what? Outside of the circle. So if the examiner wants us to now check if what? Point C lies on, what do we need to do? What do we do? Talk to me. How do we check if this will point OC lie on the circle? No. Why? Calculated the y-intercept. Okay. So wait, hold on. You calculated the y-intercept is in the circle. So you got 4 and 6, okay? Your eyes. No. No, don't use your eyes. This is what I would say. Check this. Are you aware? Let me try to draw. Circle is here, right? Okay, almost perfect. Circle is here. Are you aware that AD subtends angle B, which is 90 degrees? The same AD subtends angle C, which is also 90 degrees. And what do we say? Angle in a semicircle, it's subtended on the circumference of the circle. It means B and C lie on the circumference of the circle because it's coming from the same diameter, AD. I don't know if my reason makes sense. Okay, Gundo, you need to report that. They should give you a formula page. Give you a formula page. Okay, guys, are we okay with that reasoning? Is it fine? Whose hand is up there? Oh, okay, all right. Yes. Yes, but this time around we cannot do that because we don't even know point C. But can we try something? Zabud, let's try what I want us to try mathematically. We'll spend a few minutes on this. What you did, which is going to be a way of revising, guys, for everyone. Basically, I'm seeing that we are actually going to be doing 3.4. Let's get the equation of the circle. Let's get the equation of the circle. I'd like us to explore. While doing that, we would be revising, right? Of the circle. How do we get that? We say x minus a squared, right? Plus y minus b squared equals to what? R squared. Is that fine? What's the center? Minus 4. So it's going to be x plus 4 squared plus y minus 5 squared. We got the radius as what? Root of 17. But if we square that, it becomes what? 17. Now, if we're looking for the y-intercept, what do we know? X will be equal to what? 0. 0 plus 4, so y-intercept, we're saying 0 plus 4 squared plus y minus 5 squared equals to what? 17, right? What is 0 plus 4 squared? 16. Do we agree? I'm going to do some shortcuts, guys. I'm not going to FOIL. I'm going to move that 16 over quickly. What will that give me? Y minus 5 squared equals to what? 1. Square root both sides, plus 1 or negative 1. Does that make sense? If I look for the square root, since I'm the one introducing it, it's going to be plus or minus. So what do we have? Y will be equal to what? 6, or y would be equal to 4. Make sense? Now, there are 2 points there. What does that tell you? Y-intercept. Okay. So it means possibly we're going to have a 4 here and a 6 there. No, man, this diagram are not drawn to scale. Don't look at the diagram to judge. Otherwise, we would have taken a ruler to measure. Then it's no longer met. Okay? But the main reason why C would lie on the circle is simply because angle in a semicircle. Angle B is what? 90 degrees. Angle C is also what? And it comes from the same what? Diameter. Okay. I think we're already now done with 3.4. Guys, is it making sense though? Awesome. Determine the equation of the straight line passing through D, which is parallel to what? AB. Yes, talk to me quickly. No, we're not introducing converse here because we're not proving that it's a diameter. You are proving that a line, every time you use converse, you are proving a line or a shape. Right. What are we looking at now? Determine the equation of a straight line passing through D. You know, I like to draw. It makes life a lot easy for me. A straight line passing through D. So let's have a line passing through D, which is parallel to what? AB. It's parallel. Already, what concept are they telling us? Parallel lines have equal what? Gradient. Okay? Parallel lines have equal gradient. What's the coordinate of B though? So we have A as negative 3 and 9. B is what? X is 0. Do you want to get me the gradient there quickly? Gradient? You all did it, right? What's your gradient? What's your gradient? You all did this, so don't let's waste time with it. Gradient of AB. Sure. Can I get a confirmation? Thank you, Tapelo. -1. All right. It therefore means the gradient of that line now will also be equal to what? -1. Kancho, you didn't do this work. Huh? You didn't? What's the excuse? Guys, if I keep doing the work before you do it, you're not going to know if you can. Because right now, I'm not even waiting. I'm not even calculating. I'm just getting answers, and we need to finish up. Now, how do we get the equation of that line? Y equals to what? Mx plus c. Do I have a point? All right. 1 equals to... I used to tell people that, guys, when the teacher is in front of you, don't let the teacher do the work before you. You are using the intelligence of the teacher at that moment. Have you ever noticed that it becomes easier when we are together? And you go like, oh, it's kind of easy. But when you are alone, you're like, but we were doing this thing yesterday. And then it becomes extra terrible. Why? Reason is because you were using the teacher's intelligence to walk through. So I'll prefer you do it and get it wrong than not do it at all. What is the answer for C? You as well did not do my work. I need an answer for C, guys. I need an answer for C. That's 5. Move it over, it becomes negative. 1 minus 5 is -4. What's the equation? All right. Calculate the size of BDA. Round off to the nearest degree. BDA. BDA. I know the issue of these angles are always the challenging one. I promise you. In for this angle. The issue of these angles are always the challenging ones. BDA. Guys, why are you guys telling me 6? Wait, what's going on here? Capello and Gundo, why are you giving me 6? The value of C. And that's why I said even draw the line. Draw the line. If you draw the line, do you notice that the y-intercept is going to be a negative? All right? Okay. Now let's think through together. What are we going to do to get the value of that angle? BDA. You've got to now start analyzing a whole lot of things. Is that okay? All right. Anybody wants to share some thoughts? Let me do this. Want that angle BDA. Please look at it quickly. For those of you that have done it, let's share thoughts. Let's share ideas for angle BDA. Touch this thing, but it's refusing. Yes, Tapelo? Okay, Frederick says, can we use cosine rule? Yes, we can. Absolutely. We can use cosine rule. That's very beautiful. I was not even thinking of that. I was thinking of something else. But that looks very, very doable. Why cosine rule? Because we now have all the 3 coordinates. Make sense? The 3 coordinates. I'll tell you what I was thinking in my head. I wasn't even thinking of that. I was thinking of how to use the gradient somewhere. Gradient. Which gradient did you use? We calculate. Let's just think through quickly. But I like that cosine rule, but I want to see something if my idea would work. You said you used what? dB and dA. Okay. I was walking around thinking about those lines too, and actually making a little construction. Okay, let's see. Since we know the gradient of dA, we'll be able to get this angle. No. Okay, so hold on. I wish I could enlarge this thing. Just a second. Capello, talk to me quickly, very fast. Sorry, you're not so audible though. I don't know why. Go ahead. Okay, wait, 1 second, 1 second. Just 1 second. Let me do this. I think we have a better view this way. All right, go ahead. We're all listening to you. All right. Uh, let's see. Let me see. Let me see what you just told me. Okay, hold on, hold on. This angle and this angle. I understand it's a cyclic chord, but I want to look at those angles very well. Okay, looking at segment, looking at chord AB, right? Chord AB subtends those angles. Okay, so we're looking at AB, right? All right. We are saying it's a cyclic chord because angle in the same segment, right? Beautiful. That's a cyclic chord, I agree. Okay, that means we can use this gradient to actually look for this angle. Okay, that's actually very, very. All right, so we're looking at 3 possible ways now, right? First was cosine rule. Okay, but we've not explored our own gradient first. Tapelo, good thinking, good thinking. Thinking about the cyclic. Did we guys get what he said there? Yes, Alwande? Okay, child, you can. You just need to know how to manipulate it. Let me show you something that you can do as well on that. Are you aware that, okay, since we know that gradient, if you get that gradient, is that okay? You can get this angle, right? Just in case you are not confident of using the y. You can find this angle. Does that make sense? Right? And that is 90 degrees. Are you with me, Alwande? Okay, everybody okay with that? All right, just extending that line means since I know the gradient of AC because we calculated point C before, we'll be able to get this gradient by using what? Tan theta equals to m. If I get that, automatically I'm going to be able to get this angle. I want to take it through baby steps. If I get this one, I'll subtract from 180 to get this. But this is the Cartesian plane, which gives me an angle of what? 90. I'll be able to get that. Vertically opposite angles will give me that. This will be equal to that because of what? Cyclic chord. Right. The second one was to use what? Cosine rule. Because we know this point as what? X is 0, y is what? 6. All the 3 points. Everybody okay there? The third one, the gradient one. Okay, we are not yet done with that. We said, let me use color. So guys, I'm not going to do this question. But I will advise that you get back home and try to use all the methods to make sure you get the same answer. Trust me, it's going to expand your knowledge of maths. Have that, right? All right. So whereas I was looking at this angle is equal to this angle. Is that fine? Again, vertically what? Opposite angle. So if I can get that angle, I'll be fine. But I know that, guys, watch this. I wish I could make it bigger. Like it? Kinda. Where this is what? D. That this angle is equal to that angle, right? Which means I can get the gradient of this angle. Sorry, I can get this angle by using what? Gradient. You know how to use that, right? I can also get this one. This plus this is actually equal to that exterior angle. But a lot of people don't always see the exterior angle. So let's call this A. This would be A, right? This would be B, and this would be C. So let's look for this gradient by saying tan theta equals to what? M. Here also, tan theta equals to what? M. If you like, you can then find the rest of this angle. Does that make sense? By saying angle on A, straight line. Then I know that this gives me what? A triangle. This plus this plus this should be equal to what? 180. Then this and this are equal. I like the thought pattern, 3 different ways. All right? 3 different ways, intelligent ways as well. Okay, was that what you did? Okay, fine. That's not what you did. Please tell us what you did, because that's what I'm thinking right now. All right, beautiful. Listen to this next option. A dotted line horizontally, right? Which is parallel to the x-axis. You are allowed to do that. Okay. You named angle ADB as theta, okay? ADX. Okay, so let's call this P. All right. You found, oh, I see where you're going. You found angle ADP, this whole angle, by using tan theta equals to M, right? Okay, let's call it beta. AD found angle. Yeah, okay. We can then find this angle. Here. Okay. Alpha. Okay, hold on, let's see. So you found this. Okay, let me do this. It will make more sense if I do this. Actually, it's looking like that one is smaller. Okay. So, guys, let's check all the knowledge. He found beta by using tan theta equals to what? M. Is that fine? Then he found this one, which is actually the same thing with this, though. No, it's not. It's the same thing with this one. You found this one, okay? Then theta would be what? Beta minus what? Guys, did all the things make sense to you? Please let me know. Please get back and let's try all of them. Is that okay? Let's go back and try all of this, and let's make sure it works well. Give me a response, please. Did you master all of those things? And then we check later, right? We good? Please let's make sure we try all of those methods. Beautiful method, and that's the beauty of maths. We all seeing different things. Okay? I didn't even see the cyclic word. I didn't see the cyclic word. I was going to do this one. This one is simpler. Cyclic word is simpler. Eh? Awesome. Please, don't be lazy to go back to this. You heard what we said, right? Go back, try all the 4 methods now. We must be getting the same what? Answers. Why trying the 4? You are doing a whole lot of concepts together. You are making sure you know how to use your tan theta equals to m. You're making sure you know how to subtract the angles. And please, it is very, very important. I don't know, was this one difficult? Note that the radius of the circle, the way it looks quite easy to do. That child did not do it. When my work is not done, I know the looks. And she starts smiling as if to cover up. Did you do it? Yes or no? Can we try it quickly? Everybody. Those of us that did not do it. Quickly. This is something we need to get. Three marks. Hey, did you do it? Fast. I don't want to keep doing it before you all. Got it? I've said that gate is locked, but there's one downstairs. All right, those of you that did it, were you able to prove this answer? Just get me yes or no, so I would see. Yeah, it says show. Yeah, you just look for the radius. That's what the examiner is saying. Look for the radius. Tafelo, I don't know, it was just some paper that was called the mock paper, or something like that. But I could send you the whole paper. Yes. Did we get it? Got it? Can I see? Did you get it? How far are we? You should. That means you can get. You don't know how to get the equation of a circle. Okay, I'm going to do it very, very fast. Very fast before you know what I'll be done. So please, I want you to take note. First is to remember what the equation of a circle looks like. And you don't need to cram it. It's there on the formula page. All right? Now, this is what you do. That k is already there, right? And this is x. Now, you take the number here in front of the x divided by 2. What is negative 6 divided by 2? Negative 3. And you're done with that one. Forget about it. What do? Square it now, before we go to the other part. Square and what? Add. So what is negative 3 squared? Negative 3 squared. Negative times negative is positive. Please use your calculator. 9. We're done there. Can we repeat the same thing there? What is the coefficient of y? Coefficient of y. From the equation. Come on. What do? What do we do now? We do the exact same thing. So what do we have? Plus what? Then what do we do now? Plus or minus? We always add here. So x minus 3 squared plus y plus 2 squared equals to what? K plus 13. Now, if you compare, what is this? R squared. K plus 13. So what are you saying? R squared equals to what? K plus 13. What is R, therefore? The square root of K plus 13. We're done. Equation of a circle should not be a problem at all. Now, determine the value of K if the radius of the circle is 13. I don't see why they're asking this. Radius is 13. R is 13. We want K. There's a square root there. So what do? Square both sides to get rid of the square root. What would that give us? 13 squared, right? 169 equals to what? K plus 13. So what is K, therefore? 169 minus 13 to give us what? We are done. So please, you must be able to do it. There's no way in grade 12 that equation of the circle would not be tested. It will be tested. Guys, are we okay? All right. I just like this particular one when I read it. I think it's a very good question. A farmer owns 2 big dogs. two big dogs. He has to leave them alone for the day, but cannot leave them roaming free because they might fight. He temporarily ties the one dog with a 6-meter long chain to the corner 3,2 of a Wendy house, where its four corners are 02, 06, 36, 32. All right, so we do have all the coordinates. This dog is now restricted in the shaded region in the following sketch. Okay, is it making sense though? Tie the dog there, but the dog can only go in a circular shape up to a point. The larger circle on which part B of the curve by which the dog is bounded to the house has the equation x minus 3. And I wanted to see something here quickly. If I were to ask you for the center of this circle, what would the center be? It's 3.2 there. The sign's changing. I don't know if you can picture that on the graph. That's the center. This is r squared. R squared is 36. So what is r? 6. That's the radius. So it's like you take a rope and allow you to move around the circle. You cannot go beyond that. Okay. Oh no, what happened? Then I jumped. Where's the rest of the question? No ways. Ha. This is witchcraft. Nothing else. This is nothing but witchcraft. After explaining the whole question, then it disappeared. Oh no. Okay, I'm gonna find it, guys. I'm gonna find it. I will find it. In the meantime, do you think you can? Did anybody do this? Did anybody do this? Don't worry about that one. I'll quickly get it on board. I want us to finish this and then go to when we start Euclidean. I know we're going to finish the day there. We won't have time to come out of that thing. So that's why I'm trying to quickly do what I can do before we get into that. Sorry, I need to find that other question. Okay, Tapula, I will share. Talk to me, guys. Did you do this? Did you? I'm going to give you time, please. I'm going to give you 10 minutes because I cannot keep doing the work. Okay, Kuvadia, no, you didn't. Awesome. Please, guys, I need it done. I need this done. 10 minutes. Come, let's work. Guys, we all need to beat this time. We all need to beat the time. We need to beat this time, please. Okay, let me add 2 more minutes. Let me restart the minutes. Please beat the time. Use your formula page. Once we do this, then we go to Euclidean, right? Hi guys, did we manage? Are you stuck? Up on 1.3, Hamza? Any other person who is stuck? Kuvadia done? Come people. Tuto, where are you stuck? 4.1.3. Okay, where are you stuck? Okay, where are you now? 4.1.4. Okay, are you stuck and then you will stay there? Can you do 4.1.4? Is it needed? Is 4.1.3 needed to do 4.1.4? So why are we stuck? So go ahead and finish. It's different. You said you are stuck, not that you didn't write. Done. Are you allowed to join 2 points? What do you mean join, Kuvadia? Or how do you mean? How do you want to join? Which points are you joining? Which points are you talking about? Construct lines. Yeah, you can. As long as it's not going to be fake. So are you telling me you constructed lines? Before I finish you, you're already confessing. You constructed line what? RS. Okay. All right, guys, let's walk through. Can we? Can we walk through? Awesome. 1 minute. Okay. There's a 1 minute request. Which is granted. All right. Were you able to, let's walk through. Were you able to get M? What's the value of M? 13. M. M must be negative. Negative? Negative 3. Just by looking at where M is, I know M must be negative. Okay, let's see. What do we know? In the diagram, the center is that, you see, and they told you M is less than 0. The radius of the circle is 17. All right, we have R and S. So we do have the coordinates. Oh, it's now easy. Look, I think the major thing here that will make it look difficult is because the coordinates were not written. If you take time to just do this, you would see the simplicity in this question. Just by doing that, the simplicities are done. I'm done already. What's wrong? Okay, but just if you got P1 already, that's a straight line. So just 180 minus. Okay, I hope you see now that it's quite easy. So what are we using? Can we use a distance formula for 4.1? 4.1.1a. Distance formula will be what? D is the square root of x2 minus x1 squared plus y2 minus y1 squared. Alpha, what did you get? -3. Yeah, it's fine. You can still use the equation of a circle. It's the same thing. The distance formula is actually the equation of a circle because it's the circumference. Okay, so we have this as what? 17. 2 plus 13, I think, squared plus m plus 11. Is that what you guys have? Is that what you have? That should lead us to the answer. Yes, it's minus 11. So it's y2 minus 11. I'm using? Yeah. Oh, you used point R. Oh, okay, yeah. So, but we should get the same thing. Okay, let me walk through. What is 17 squared? 289, I think. 289. What is 2 plus 3? 15 squared. 2 to 5. Bring it over. Minus 2 to 5 equals to m plus 11 squared. What is 289 minus 2 to 5? 8 minus 2 is 6. 9 minus that, 64. So 64 is m plus 11 squared. Can I find the square root of both sides? Plus or minus what? 8 will be equal to m plus 11. So m plus 11 equals to 8, or m plus 11 equals to what? -8. -3, or m equals to what? Here I'm getting negative what? 19. Correct. Is this correct? M plus 11. If I move the 11 over, I'm correct, right? Negative what? 19. But it cannot, can it be negative 19? No. Because it's a y value. Check. The y value here, we already know is negative 11. So negative 19. Okay, do you know where negative 19 is? You know what this means? It means I could create another circle down here that will still be 17 units away from point S. Okay, so makes sense now, right? So by we need to reject one answer. M is negative what? 3. Determine the equation of the circle in the form. That is now simple again. What is B going to be? X minus 2 squared plus y plus 3 squared equals to what? We're done there. 4.1.2. Determine the gradient of NR and the gradient of NS. Guys, give me your answers. We all should be able to do this one. What is the gradient of NR? Talk to me quickly. Negative? Can we confirm this answer? And gradient of Sn will be equal to what? Is it confirmed? All right, we don't want to waste time doing that again. Lovely. Now, the tangent. Okay. The tangent at S and R intersect at P. Calculate the angle of P2. Oh, that's where you guys were stuck. Because you saw 6 marks. I know you all. Once you see lots of marks, you conclude it's difficult. Huh? Not everyone, but most of us. We look at the marks to think that's the level of difficulty. Okay, let's see. What would I do here? Let me enlarge this diagram. I would use my gradient kind of thing again. After this, guys, I'm going for Euclidean because we need some time there as well. All right, let's just make it bigger. Okay. So we're looking for which angle again? P1 or P2? We're looking for P2. Oh yeah. We do know this line, right? We also know this. We got the gradient of this as what? Negative 8 over 15. While this one is what? Positive 8 over. But this is a radius and that's a tangent. 10 rad. They are perpendicular to each other. And when they are perpendicular, what happens? The product of the gradient should be equal to what? Negative 1. Which means the gradient here would be what? Negative 15 over 8. Change the sign and reciprocate the number. What will be the gradient here? 15 over 8. Which means I can now get this angle by using tan theta equals to m. Angle of inclination. Right? Let's call this alpha for clarity's sake. If I use this other gradient, guys, I can get this angle. Let's call this beta. It's always measured from the x to the line, anti-clockwise, which means I have this angle. And, all right, this angle here is actually equal to that angle there inside. Does that make sense? Vertically what? Opposite. I want to go the simple way that most people would have gone through. And this angle here, I'll get that angle. Then P2 would be a sum of these two angles. Okay, let me call it, I want to label all of this. So this is going to be alpha, right? This one, let's call it what? Gamma. Angle P2 will therefore be gamma plus alpha. Why? Exterior angle equals to what? Sum of opposite interior. I don't know if it makes sense, but let's do it together. First, excuse me, let's use the gradient of PR. We said alpha, right? Tan alpha equals to MPR. Tan alpha, what's the gradient there? 15 over 8. Do you want to give me this angle quickly? This very fast. Everyone, type in. 61, 93. All right. So this angle already, we know this angle now as 61, what? 93. I hope it makes sense to everyone. 61,93. Which is already this angle here now. Let me use red. Does that make sense? Now let's use the gradient of PS. Tan beta equals to what? MPS. What is my gradient there? Negative what? Negative 15 over 8. So what is your beta? Negative. How can your angle be negative? Once you have a negative gradient, whatever you get, you need to add, say, plus 180 on your calculator. Because that angle cannot be negative. What's your answer here? Actually, it's the same as this angle, right? Okay. So you're going to get negative 61,93, right? Plus 180. That gives you what? 118, comma? What is this angle that we now have found? We have found this angle, right? Let's use a blue. We have found this angle. Guys, can I quickly just draw this out for us to make life easy? This is what we have. That's our x-axis, right? We have that, and we have that. This is now P1, and this is P2. Already we know this angle now. What is this angle? 61,93. What is this angle? 118, which automatically makes this one to be what? 61,93 as well. Because 180 minus that. Now, the choice is yours from here. Whether you want to find P1, then subtract from 180, or P2 is the sum. It's an exterior angle, which is equal to the sum of the two what? Opposite interior angles. You went the long way. You found P1 first. It's okay. It's okay. So, guys, when you are doing a question like this, listen, your answer sheet comes with a diagram. Is that okay? So you are allowed to do exactly what I'm going to do now. Check. You are allowed to do, so your answer sheet will come with a diagram on its own. You are allowed to call this Q and call this, is there any, no, there's R, right? Let's call this what? Y. And call this Y1, Y2, Q1, Q2. You are allowed, but that labeling must be on your diagram, on the answer sheet. So it means when I'm answering this now, I will then say that what? What did I call that point? Y2, therefore will be what? 180 minus 118, what? 07. That allows the examiner to see what you're doing quickly. You say, okay, this person said Y. Where is the Y? Don't make us guess. Tell me that that's Y there. Then you can say, oh, P1 plus Q1 plus Y2. Do you see that, right? So use your letters, use your numbers, but make sure it's on the diagram. Because sometimes you might be confused on how to write the whole shenanigan. All right. So I know that P2, therefore, would be equal to what? Q1 plus P2. Exterior angle is equal to what? Sum of opposite what? Interior. Therefore, P2 will be equal to 2 times 61,93. Which will give us what? Talk to me, talk to me. 186 degrees. All right. Are we okay? So it's a lot of analysis that goes on with such questions. So please, you are allowed to do your labelings just to make it clear. You know, you quickly explain yourself to the examiner. I'm making this A. I'm making this B. B1, B2. Makes it also easier for you to refer. Yes. You have to write it down. How do you mean? Yeah. No, just once you write it in your question paper, in your answer sheet, not your question paper, your answer sheet comes with a diagram. Label it on your answer sheet. Write it down. How do you mean? No, don't need to write let. You need to write let. Once I get here, Y2, I'm going to look straight into your diagram. All right? That where is Y2? Oh, but I see that you labeled that as Y and Y2. Because how are you going to even label this point? You see, it has no label. Let what? P, what? You see, it's not making sense there. So there's no need. As long as you have that Y labeled in your diagram, I'm going to check. Oh, this learner said Y, but there's no Y here. Can I go back to his diagram? Oh, this is what the learner referred to as what? Y. Therefore, y2 is this angle. Swap Q and Y. Why would they swap? If you label it, why would they swap it? Why would they swap it? Uh-uh. No one will swap it. As long as you label it. That's why you need to label and make reference to what you have labeled. Okay. I know time is running as quickly as possible. Guys, look, the first set of your Euclidean, no one should be struggling to get marks on that side. Please, get your 2 marks, find the angle. I taught you all the secrets of getting how to get this fast. Trace the source of the angle, describe the nature of the lines. If you want to do your own thing again, you're going to spend a lot of time, which is time that you don't have, especially for paper 2. Can't be wasting time. So you need to get this fast. Did we try this? We did. Did you try? Let's see. 4 minutes, everybody. In case you didn't try, because I know Tuto did not try. That child, I don't know what she was doing the whole day. Quickly, guys. Tuto did not try. Kancho did not do it. I'm reporting you to the whole world. Same with Alante, didn't do it. Yeah, I'm reporting you to the whole world. And I'm hoping your mom just comes across this video and hear your name. What? My child? Yeah. Oliphant, same story. Somebody's hoping I won't mention her name. Did you do it? You are looking. If you did it, you would know whether you did it. It's not that you are looking for it. Oratile did not do it, just in case Mama listens to this video. Oratile did not do my work. Tapelo, I'm seeing your answer now. P2 as 56,14. Guys, by the time I hear green, 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 you must be done. Please. Just by looking, I'm already done with the first one. A2. P1. Done. B1. Oh, what? Like, really now? I did all of this in 30 seconds now. No. Listen, I only used the same tricks I gave you to do. My problem is you guys want to do your own things. Oliphant, you're doing your own things. Go my way. My way insurance is safer. Pays better. Shy. Just say line drawn from center, full stop. No one expects you to write the whole story. And you You must go know those theorems by words, guys. You know, they'll put those, fill in the gap. Mm. Are you done? Ah, thinking about what? Child. Ah, elephant. What are you saying? Are you done? Really, guys? No, man. Please, guys, use the things I taught you. I promise you. I don't know what I'm going to do to force you to use what I taught you. Stop doing your own things. You are now pity patting yourselves. No, guys, don't do your own things. Do the things. Only two things that you're doing here: tracing the source of the angle, describing the nature of the line. And you know your theorems already. Look, what are we looking for? I'm not even going to write, guys. We're looking for what? A2. Look, can we describe the nature of the lines around this angle? Are you aware that that is a radius? Oh, if it's a radius, this is also what? A radius. I already know that A2 is equal to what? B2. My job is to go and get what? B1. Or sorry, O1. And that is angle at the center, which is 2 times angle at the second. This is now what? Trying to understand where. You're already done with that. Don't look at look at what you are supposed to look at. You see that once I told you you are doing your own things, you are looking everywhere. No, vele, na. You are looking at everywhere. That 250, you have nothing to do with that 250. It has nothing to do with you. You have nothing to do with it. Everybody's going their own ways until you need it. Sharp. Aha. Can you see the guys? I'm done already. And this is what you do during reading time tomorrow. Oh, I got my tomorrow right today, right? Yeah. Yeah. I like the way I use tomorrow and today now in the same sentence. Lovely. Got my tomorrow right today. Because yesterday I kept saying tomorrow. Guys, please, is it making sense now? So what is this angle going to be? 180 minus 30 will be 150. Divided by 2, 75 cents. Holy fans, we are done. Just like that, like boom, boom, boom. Get 4 marks. Imagine. How do you write that statement down? How would you write it down? First, I'll say what? O1 equals to what? 30 degrees. Angle at center equals to what? 2 times angle at circumference. But you're allowed to say circum. Done. A2 equals to what? B2. Angles that are what? Opposite equal what? Sides. Therefore, A2 is 180 minus 30 over 2. 75 degrees. Boom. You are done. Now you go for P1. P1 is just 90 on its own. It's a theorem on its own. Yes, sir. You can. But I prefer you go this way. Because that you say sum of angles doesn't really mention that A2 and B2 are equal. Which way is it given? Told you that. That's it. But that's why I'm saying I would prefer that you include this statement. That's why we are saying, so this statement actually solidifies the fact that you are saying divided by what? By 2. Okay? So you can even now add this here, sum of angles in a what? In a triangle. Possibly. So give as many as you can, just to be safe. Every step that has a reason, just give it. Guys, what is P1? P1 equals to what? 90 degrees. What's your reason? Huh? No, I want you to listen to what you... Exactly. You said line. Yeah, you said line drawn. No, let's learn. Let's learn from it. You said line drawn from the center to the midpoint of a chord bisects the chord. It's already the midpoint and more bisect. Line, if you want to write it the whole thing, line drawn from the center that bisects the chord is perpendicular. All right. So the line drawn from center, normally we would say line drawn from center perpendicular to the chord will what? Bisect. That's the original one, right? Line drawn from center perpendicular. Now I am going the other one. So what would I say here? Converse. Makes sense? The real one is line drawn from the center perpendicular to the chord will bisect. But now I'm going the other way. So I'll just say what? Converse of line drawn from center. You're done. What is B1 there for? Okay. You know what also helps me? What helps me with Euclidean as well is whatever angle I get, don't write too many things. Write it down. And the good thing is you have two diagrams. One in your question paper, one in your answer sheet. So when you get an angle correct, go and write it in the question, in the answer sheet. It helps you see things a lot better. So right now, I will do this. Now, I'm looking for B1, and I see a triangle. Now my 250 is going to play a role. I cannot get this angle without getting what? O2. And I know angles around a point. So what is O2 going to be? Is it 80? You sure? What's your reason? Angles around what? A point. Therefore, yep. B1 equals to? But you didn't write anything about O2. Uh-uh. So how did you calculate the 10? No, you must write it. See where the examiner is going to mark now. Now, B1 equals to what? 10 degrees. Sum of what? Angles in A. So it's statement and reason, statement and reason. And you might get 1 mark if your teacher is kind. So write every step that leads you to the answer. Is that okay? All right, guys, are we okay here? Make sense? Please, so don't leave anything behind. Thank you, Taps. Okay, we okay? Awesome. Why your face? I wish you could see your face. Is like, okay, we are getting there now. Eh? 2 minutes. All right, there you go. You have 2 minutes. I'm kind. I'm a nice guy. I'll make it 3. I'm a nice guy. Mr. Nice. Mm. Time up, time up, time up. People were laughing here at me. They didn't get it. Oh, oh. What are we proving? Determine the size of what? QPS. Me, I'm done already. Answer is 80. 77. Okay, calm down, calm down, calm down. Don't eat me up. Yeah? Is it here? Send it here now, quickly. Let's do it together. Which section is it? Okay. All right, let's see. Maybe it's on the slide. Let's see. Guys, is it 70? All right. Already I know that this is going to be 70, right? This angle is 70 degrees. Why? Opposite angles of what? Cyclic what are? Supplementary. And then I know this angle and this angle are equal. Angle in the same what? Segment. Boom, done. Next. 5 minutes. So this is what I'm saying, that guys, there are some questions we just get quickly. You've not even started. I should add 3 minutes. Okay, I'll add. Because I want you to do it. You see, the joy I'm going to have is when you get it right, not in me getting it right. Trace the source, describe the nature of the lines. I think it will help you. Just those 2 things. All right, everybody. Um, let's see what. Let's see how to check this. Were you able to? Was everybody able to do the first one? Everyone, you sure? You're able to do the first one on your own. Okay, this is what I did. I also did the first one. I haven't done the second one. For the first one, like I said, let's look. Like I'm saying, what saves you time here is the fact that you're not going to be looking everywhere. Is that okay? Let those tips run in your head. Trace the source of the angle. This is coming from what? AR. And AR is a chord. Quickly look around that chord. What do you notice? There's a tangent. Automatically, there's a tan chord there. It means this angle is equal to what? X. What's your reason? Tan chord. You see, follow those cues. You're not even wasting time. 10 seconds, you are done with the first one. Instead of you trying to figure out, some of you checked A, 4, 5, 6, 7, 8, 9, 10 to find. No, we don't want to waste time. Already there's an X here. This and that. Vertically what? Opposite. I'm done there. Second one. What do you notice now? Trace this is a chord, right? Nature of the line. And this is what? A tangent. You see, I'm describing the nature of the lines around my angle. I'm noticing a tan chord. Automatically, P2. Check. It doesn't take you. Do you understand that your reading time? You are done. Reading time. Proof that APTR is a cyclic chord. What's going on in my head is right now, what are the properties of a cyclic chord? Opposite angles are supplementary. Exterior is equal to opposite interior. Angles in the same what? Segment. So those are the three things that I'm going to be playing around or playing in my head. APTR. Okay. Did I get it right? APT. Yeah. All right. So I see, first thing I'm looking at quickly here is, I didn't get it yet, but this is what I'm thinking. I see some exterior angles here. Because why am I saying exterior? Exterior comes from what? An extended line, right? So if I can prove that R2 is equal to what? P1, that'll be done. So let's just put these markers there, red markers. Or if I can prove that, that's another exterior, right? Let's use a blue one. If I can prove that what? A4 is equal to what? The whole of T. I'll also be done. Am I right? Exterior is equal to what? Opposite interior. Those are two things I'm seeing. Okay, let's see. We are now looking for, what are we looking for? We're looking for what? Either P1 or R2, or looking for T and what? A4. Okay. Sorry? A1. Yeah, P4 would therefore be equal to what? A1, right? Yes, Tapelo? You can also do that. All right. Let P1 be equal to Y. It means that you need to prove that R2 will be equal to Y. Okay. So let's walk through together. Let's walk through together. We only know three angles that are equal to what? Is it 3 or 4 now that are equal to X? 4 angles are equal to X, right? Okay. So, yeah. Let's see. Let's see. Blah, blah, blah. What are we going to do? If I look at my P1, okay, let me get a highlighter so that I don't mess this thing up. If I look at my P1, what can I say? P1, that's a tangent, right? And that's a chord. Make sense? So, which angle would this one be equal to? It should be equal to n. Remember now, just by me thinking of the properties, I'm already limiting what I should be doing. Okay? Like Tapilo said, if P1 therefore is equal to y, it means n is equal to what? Y. Does that make sense to us? What's the reason? 10 chord. Okay. So already we know that, okay, we know all of those. What else? Let's go play around. Yep. PQ parallel to what? All right. Yeah. Yeah. Okay. Check here. I see where you're going. This is x, right? And that is also equal to what? X. So that, and that. It means that this line and this line are parallel. Okay, let's see how far that's and that's going to be converse of what? Converse of alternate what? Angles. So let's put it there. Already we have that. So if those lines are parallel, if those lines are then parallel, how will that assist us? Okay, if this is x, this is x. Now let's use those parallel lines for fun angles, right? Let's use, where's my highlighter? Fun angles. Remember, don't forget what you're looking for here. Don't. By the way, can I do this? Can I try something? Since I have this as x and this is y, what is A4 going to be? 180 minus x minus y. Does that make sense? Okay, even before I go to those parallel lines. This is 180 minus x minus y, which is also equal to this, 180 minus x minus y, which allows me to even get my R2 using what? Sum of angles in a triangle. Let's try it, what R2 would give us. So I know that R2 plus x plus a should be equal to what? Let's check it. Plus x. What is our a? 180 minus x minus y equals to what? 180. By the time I move this 180 over, what is R2 going to be? Oh, this x will also cancel this x, right? Moving that over, check, we are done. R2, I didn't even use the parallel lines. Did you use it? Oh, you proved similarity. Okay, but I didn't even use it now. You only saw it now. Okay, but I think I just like what I did. It makes sense. Yeah, I don't. You might look. We are going to see different things as we go on, but I think I just like what I did here. And what assisted me here was I already created a pathway. I'm just trying to put the dots in. Let's go back to the third pattern. They said prove that it's a cyclic chord. We revised quickly the properties of what? A cyclic quadrilateral. We're trying to now figure out, okay, because there's no numbers here, it's very difficult to get 180. Let's work through the external one. Exterior must be equal to what? Opposite interior. So that means my focus shifted quickly to those angles. Now I'm dealing with these angles. Tangent and what? A chord. Automatically gives me what? That. This is in a triangle. This gives me 180 minus x minus y. This is connected to this because R2 is in this triangle. Vertically opposite what? Angles. Ta, ta. Make sense? And your answer here will be converse now. Is that okay? Whenever you prove a tangent, prove a line, it will be converse. Now, Fiat, did you get it? I just repeated it now. Okay, let's write down the answers. Probably help someone. Let's write down the answers. This is what I would have written. Okay, I'll follow Tapelo's system. Let P1 be equal to what? Y. So what do we know? P1 is equal to N, which is equal to Y. What's your reason? 10 what? 10 chord. A4 therefore is what? 180 minus x minus y. Sum of angles in a triangle. A1 is equal to A4. Vertically what? Opposite what? Angles. Make sense? Now, what do we know? R2 is equal to what? Y. Sum of angles. Yeah, what? So we are saying P1 therefore is equal to what? R2. APTR is a cyclic quadrilateral. What's your reason? What's your reason? Converse of exterior angle equals to what? Opposite interior. I want to check something. How many lines do we have? 1, 2, 3, 5, 6. You have 8 lines. All right. And you can see, guys, look, don't start writing what you're thinking. Some of you just look at it. Some of you are very brilliant. You just look at the question. Okay, P1 equals to E2. You write. You don't even know whether it's going to take you to the answer. Meanwhile, you have an answer sheet, remember? Yeah, and it comes with answer sheets tomorrow. Yes. Paper 2 comes with its own answer sheet, which means you are limited, although you can ask for more. But yeah, there's extra, but some people just write things that are not relevant, that will not even. Somebody's talking about T1 is equal to T2. Let's assume that T1 is equal to. Let's assume that T1 is equal to T2. They're not at all. So, guys, once you see proof that it's a cyclic quadrilateral, think of the what? The properties, and try to figure out things to match the properties of what? A cyclic quadrilateral. Make sense? Awesome. Take a picture, people. Done. Okay. Again, do you see this one? Prove that what? PS. This one, you use the if statement. Let me give you a hint, then I'll leave you to try. When they say PS, prove that PS is a tangent. You are going to say, this is how you start. If PS is a tangent, then which angle should be equal? So let's make this a tangent. Now, what do you notice? We're going to have a tan chord there, right? It means P1 should be equal to which angle? Angle R1? Never. It must be on the circle. Said R1. Yeah, it must be on the circle. Is that okay? You did it. So, guys, this is what we are trying to prove. If you can prove those two things, do you see the way I started? I made PS what? A tangent. Then I know I'm dealing with what? A tan chord. If I can prove those two, then want to try? Want to try? Look, let P1 be X. Let's try to walk through. Let P1 be X. I see alternate angles here, right? S1 would automatically be equal to what? X. What's your reason? Alternate what? Angles. It means you need to prove that T must also be equal to what? X. Okay. Let's see what we can do. Huh? Co-interior what? But if you use co-interior angles, what are you going to, how are you going to work it out? Because co-interior angles will include all of this. It might work, but I don't know if it would, because I don't even know what P2 is. Okay? But it doesn't stop you from trying. Okay? We have that so far. Let's see. Let's see. Okay? I don't know angle T, but let's go your way. Let's make this Y, for example. Yep. Okay? T. We're proving that PS. SR. Not really. It's already a chord. Yeah. We're proving that P. Oh, sorry. We are proving that what? PS. I read the question. I was looking at PQ. Okay. Sorry. My mind went to PQ as a tangent. All right. Sorry. You also did that, right? Okay. Sorry. My mind went straight to proving this one. Prove that PS is a tangent to a circle TSR. Ooh, I would have gotten that wrong. So there's no circle TSR, right? Can we draw it? Just draw. You know, it doesn't have to be perfect, but you're just going to draw. Okay. You know, I think I'm almost there, right? Almost. When I do this, I just like a bit of perfection. Push up, push up, push up. Okay. There we go. Wait. Okay. If PS is a tangent, then what? So it means this is going to be my what? Tangent. Is that fine? This is going to be what? A chord. So this angle should be equal to that angle. We see the same thing that falls back to the same thing that we need to prove. Okay, so we need to prove that this and this are equal. Okay. All right, we need to prove that that and that are equal. Okay, so we've shifted focus from everything. We're looking at those angles now, right? Okay, if we look at this angle though, let this angle be x, false that this one is also equal to what? X. We agree. Awesome. Now, I was saying earlier on that we're not looking for this. We're looking for this. Let this one be y. Let's just think through first and we'll see what the write-up will be. This is what's going on in my head. That's if I make that y. All right. Then this one will be what? 180 minus x minus y. Does that make sense? Sum of angles in a triangle. Now, T2 plus S2 must be equal to R1. Exterior angle is equal to sum of opposite what? Or if you see it that way, check. Since this, look at this, corresponding angles, right? This angle should be what? X plus y. Does that make sense? F. That makes sense to us? All right. We're getting close to T. If we can get S, huh? Really? Okay, what are you thinking? P1? Oh yeah. P1 is equal to what? T. Beautiful. I didn't see that. Tan chord. All right. And we want this to be equal to that. Done. Good. I didn't see that P1 equals to X. All right. So let's write our answers down. So you see that the if statement works. It quickly restricts you. You are not playing around so many things. It tells you which angle to quickly focus on. What was our first thing? Okay. You want let P1 be equal to X. That can also be done. It means that what? P1 is equal to what? S1, which is equal to what? X. What's your reason? Alternate what? Angles. RS is parallel to what? PQ. Make sense? What else? But the same P1 is equal to what? T. Why? Tan chord. So, S1 is equal to what? T. Therefore, PS is a tangent. What's your reason? Converse of tan chord. Are we okay? Did it make sense, guys? Thank you. Thank you. So we didn't need all the shenanigans I was talking about. Guys, when they say proof, just use the if statement. It saves time. You are quickly looking at what you need to do. I want us to spend the remaining 30 minutes on the last questions. You know, p squared over what squared equals to that squared over, yeah. Just take a picture, please. Time. Huh? Okay. Aha. Did you do this one? Got it. Okay, let me show you what I would do in a question like this because of time. In the following diagram, CE is a tangent to the circle ABCD at C. CB is parallel to EA. Prove that AB multiplied by CD. Look, when I see this, can I quickly tell you what I'm going to do? Okay, I want to see what I'm going to do. This is what I'm going to think about and how I'm going to do it. I'm going to start from the answer. If you check my hints, tip that I gave you, when you see an algebraic problem, start from the answer, use the answer to find the triangles that they used. Because these are very difficult if you just want to look everywhere. So look at what I'm going to do. I have AB multiplied by what? CD equals to what? BC. For me to get this, I must have cross multiplied. I'm going to try to create that cross multiplication. This is now wisdom playing. AB, it means CD must be here. Are you seeing what I'm doing, right? So when I cross multiply, I will get that. Okay? BC must be here. And ED must be there. Now, check the letters. Does it form a triangle? What letters do I have here? A, B, C. Go and check if the triangle doesn't exist. Switch those letters. Is that okay? All right. For example, let me. I see that ABC exists, but let me show you what I mean. If I had written this at first, because Elena will be saying, "How do I know that I should write ED there?" What if I had written ED here? All right, and I had written what? BC here. Are you aware that I have too many letters on one side? I have 4 letters, and I'm looking for a triangle. A triangle is supposed to have how many letters? 3. So I already know that ABED is going to give me a problem. I need to switch it. Get the whole idea? So what do I have? BC and what? And ED. Which letters are here? ABC. Does it form a triangle? Yes. ABC. Which letters are here? CED. CE. Oh, yeah. There we go. It means I am going to be working with just these 2 what? And what am I supposed to do? Prove that they are similar. Is that okay? Before even putting it in order, now we know that we are working around this angle, this angle, this angle, and you are only looking for how many of them? 2 of them. Okay, my beautiful learners, let me use a red here for D1. What can you tell? That's a cyclic chord, right? Do you already see that exterior angle here is equal to what? Opposite what? Interior. Oh, so already I know that D1, do you see where I wrote my D, right? Is equal to what? B. I'm looking for one more. Let's get a pink one. There's a parallel line. Will it help us? No. Oh, but there's a tangent. There's a tangent and there's a chord. This angle. See that chord there? But A1, nice question. A1 is not in the triangle that I'm looking for. So this angle is equal to this angle. Now you are stuck that Mara. I wanted it to be in. We got to force it in now. Now, what do you notice? Danko. We are now done. A1 is now equal to C1. You see that we are done? Already now we have proven that C1 is equal to what? C3. Which one is the red one? D1 is equal to what? B. Automatically, A2 would be equal to what? E. Similarity. Once you write that similarity, write your ratios, boom, 6 marks is done. I promise, I don't know which other way to teach this. This is what I do. I try to get into what the examiner was thinking by finding those triangles. Yes? Find? I have no idea. And I don't even want to try. Question is it possible to find E? I don't want to try. But did what I do make sense here? So use the letters, find a triangle. For you to get a ratio like this, it has to be what? Similarity. Okay, there's a request of a brain borrow. Talk to my manager. Huh? Who's my manager? Sue. Because people want to borrow my brain now. Okay, do I need to write this down, guys? For clarity. Okay. We said B is equal to what? Angle B is equal to angle what? D1. What's your reason? Exterior angle is equal to what? Opposite interior angle. Make sense? All right. What else? C3. Now, here's the deal. C3 is equal to what? A1. What's your reason? Tan what? Chord. But that A1 is equal to what? C1. Alternate what? Angles. AD is parallel to what? BC. Therefore, C3 is equal to what? C1. We good? Good. Which question is it? Okay. Okay. All right. Okay, let's see. Are we okay? Are we good now so far? So already I have this angle, this angle. You know what I would now say here? This is how I would write mine. I'll say consider, just to help the examiner, triangle what? CED and triangle what? CBA. Let me see the question. Okay. Now you're scaring me. Okay, you're scaring me now. Okay, there's a question here that is, I think the next one, they're telling me it's going to sweep me off my feet. So, okay, let's try. But guys, are you okay with my presentation so far? Awesome. You okay? Okay. Now, guys, listen. We now we need to quickly arrange this in order to make life easy. Since we are now focusing on our triangles, is that okay? Let's arrange it to make it very easy for us now. Already we said C3 is equal to what? C1. All right, C3 is equal to C1. I want to arrange it in order. C3 is equal to what? C1. D1, you see I'm putting D1. They fall under the same what? Triangle. D1 is equal to what? B. Therefore, E will therefore be equal to what? A2. What will be your reason? Third angle. Now check the labeling. CDE will therefore be similar to what? Triangle CBA. What's your reason? Angle, angle, angle. Can we then write the ratios out? What do we know? CD. Okay, I'm going to write it as following alphabetical order. CD over CB, but I'll say what? BC. Make sense? Alphabetical order. Equals to what? DE over what? AB. DE over, it's BA, but AB. Then what do we have? CE over what? AC. What are we looking for? We are looking for what? AB, AB, and CD. We're looking for BC and what? DE, which is that, right? So I don't need this third one. But there's nothing wrong in writing that first. And then you put your ticks like that. Therefore, can we conclude? AB multiplied by CD equals to what? BC multiplied by what? EG. Done. So the whole idea is to get the triangles where those things are made from. Yes, sir. Yeah, because it's just on top. If I was starting from a different question now, then put similar triangles. We okay? I'm going to the next question. No, C3 is equal to, I was just writing here, we did all the explanation earlier. C3 is equal to A1. And this is alternate angles. This one is equal to this. Done. If this is equal to this and this one is equal to this, what does it mean? It means this one is equal to that because they are both equal to that. Okay. Can we go for the next question? My heart is beating, beating, beating so fast. I've heard a lot. I'm hearing things about the next question. So, 5 marks. This is already the way I'm looking at it is already tight. I'm done. Okay, forgive us. Forgive us. We make mistakes, guys. Don't worry. Okay, wait. Okay, hold on. Hold on. Before we start laughing, let it deal with me too. In the following diagram, AC is part. So I know this is proportionality already, right? No matter what we do. Okay. AB ratio BC. AB is 1 to 3. So X and 3X. Remember, those ratios are not lengths. Okay. I'm interpreting first before I start getting funny. AGGF 4 to 5. AGGF on the side 4. Can I say 4Y? And then what? 5Y. What are we looking for? Value of FE. Amen. This is a problem. But relax. Yeah, let me breathe. Oh, okay, guys, let's see. This is what I would do. I know I'm working with CD and F, so I've got to find that side. I've got to focus on getting that side. Is that okay? And I see here, this is what I'm going to work out. I can actually work out CD quickly by using this. Because I've got a parallel line and I've got a parallel line. Does that make sense? All right. Can I just quickly think through first before I start writing? All right. This automatically becomes what? 4K over 5K. Does that make sense to everybody? Make sense? All right. 4, 4, 5, 5. Beautiful. Okay. But then I've got to find a way of dealing with this DE. Okay, let's see. I've got to find, let me clean this red. You guys shouldn't have told me what you told me. Should have told me what you should have just allowed me to walk through freely. Okay, but not the train smash. Now, well, how would I use this X and 3X? It would actually assist me. Let me get a highlighter here. Ta, 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 right? So this becomes what? 1, and this whole thing becomes what? 3. Here's the problem I see. I've got to use a different letter. I'm working with a different thing. So maybe you'd find something better. Can I use what? Q. Okay, so this is what? Q. And the whole length here will be equal to what? 3Q. Make sense? Awesome. I think I'm done. I see something in my head. I hope it works. Now, in order for me to be able to work this out, I need to write them in the same letters so that it can cancel out. I noticed that. What is this whole length in terms of Q? 4. So 4Q equals to what? 9K. Now I can write the K in terms of the Q, or I can write the Q in terms of the K. Hold on, what am I looking for? FE, right? Okay, FE is already written as Q. Can I go and write CD in terms of what? Q. To do that, I'm going to look for K. Can we divide both sides by 9? What is K? 4Q over 9. Now, what is my CD, by the way? 4K. So CD equals to what? 4K. Instead of writing that, can I say 4 times 4Q over 9? That gives me what? 16 over 9 what? Q. So what is FE? FE, therefore, over CD, what is FE? It is Q. Am I right? Over, what is DC? 16 over 9Q. Q cancels. I have 1 there. So 1 divided by 16 over 9 will be 9 over 16. Yes. Wasn't bad, eh? Oh. But did what I said make sense though? Did I lose you? I should repeat. But the idea is to make sure, look at the question, is that okay? And let the question make sense to you. And on one side, we have different letters, but bring them together. Find a way of bringing the ratios together. Okay, let's go through again. Yes? If they used, no, don't use what? Because you already used X on that side. It's not nice. Use a different letter. Because once you use X, you are saying they are the same. But is what I'm saying, making sense though? Okay. Guys, let's go through again what we did. Now, what did we say? First is to write down the ratio, right? AB ratio BC. X and what? 3X. Everybody okay with that? Next one. AG GF. 4Y. 5 what? Y. You've not done anything. We are still sitting on 0. But examiner wants us to find what? FK over what? DC. So what I saw is that it's on the right-hand side. What can I do about the right-hand side of this question? Since it's proportionality, is that very clear already? Let's start writing our answers down. What are we going to write? AG over GF will be equal to what? CD over DF. What's the reason? Prop what? Theorem. Which lines are parallel? AC is parallel to what? GD. Do we agree? You're recording. AG parallel to GD. Therefore, can we say CD over DF would be also equal to what? 4 over what? 5. Am I right? We're good. Okay. So, but when I move to the other side, please change letters. Don't repeat any of this. Okay? And this is what? Is that fine? However, this I still need to get what? FE. But just looking at FE, you can see a proportionality here already, considering that other triangle. Where's that triangle? This triangle, right? Can you see that proportionality? Which allows me to get this part. Make sense? So, AB over BC will be equal to what? FE over EC. Let me write that down quickly. AB over what? BC will be equal to what? EF over CE. Again, prop CE, not D. Prop theorem. Which lines are parallel? AE parallel to what? AF, right? And this one therefore means that EF over what? CE would be equal to what? 1 over 3. Do we agree? Did I make a mistake? AB over BC will be equal to what? EF. Okay, wait. Oh, it's supposed to be BE, right? EF over what? EC. We okay there? Which lines are parallel? AF parallel to BE. We're good. Okay. So we are looking at. What are we looking at? FE and what? Okay. Z and what is this? 3Z. But if you look at the length and compare the length in terms of the letters, can we then say that 4Z, because it's still CF, right, should definitely be equal to what? 9K. Whatever the value of Z is, whatever the value of K is, they are both what? CF. Remember, the whole idea is to get the same letter so that we can cancel some things out. All right? So I'm trying to find K now, or find Z in terms of what? K. Because I want to get rid of K completely. Because I see that this is what? A Z. What do we do? By? No. We want to get rid of K. So we say K equals to what? 4Z over what? 9. Does that make sense? Now, what does this mean? CD, which is equal to 4K, now becomes 4, but instead of writing K, what do we write? 4Z over 9. But what? 16Z over 9. We're good. Now, do you notice we have both FE and DC in terms of the same variable? So FE over what? DC. What is FE? Z. What is DC? Don't use K. It's 4K. But don't use K because you're going to be bringing in a whole lot of things. CD is equal to what? 16Z over 9. You notice the Z simply cancels out, right? This is 1, guys, when you divide. So you are simply saying 1 divided by what? 16 over 9. And when you divide, what happens? Reciprocate. That becomes what? 9 over 16. Beautiful question. Love it. Love it. Love it. Guys, did it make sense to you? It's been turned? 4 minutes. I apologize on behalf of the person. Huh? Okay, okay. Oh, all right, guys. Anyway, this was the last question on this slide, though. Did it make sense to you guys? Did it make sense? Somebody sent me, okay, before we go to your question, somebody sent me a question. I want you to try for me. Let me write it down. Elena sent me a question just now. But I hope, guys, you're okay with starts, né? Just go over your notes and start. If there's any question, let me know. Prove that prove that sine 2x minus 10x over cos 2x is equal to 10x. I think it's 5 marks. Quickly. All right, Tapelo. I'll send you a picture of my stats, the correlation. Okay. Just remind me after the lesson. Find the position of our Q1 to be 3,25. What do? You go down. 3,25, you go down. But just count, man. I think it's easier to just count. You get less confused if you can count. Divide your start into two first, then divide the lower part into two again. You get less confused. Let me put a time frame here. 3 minutes more. So we can look at your question, the question you sent. Someone sent this question while we were busy here. While I was, on my phone. All right. I see done there. Okay, let's see. Guys, when you see that you're supposed to get 10, think in your head your answer is supposed to be sine over cos. Is that okay? So you're working towards that. Can we quickly do sine 2x? What is sine 2x? 2 sine x. Why minus? Minus sine x over cos x. Okay, can I put over 1 here to simplify things? Now look at what I'm going to do. When I see this, I don't know which of the cos 2x to use. I'm going to keep it. I'm going to keep it. So it's the left-hand side, right? What do we do here? I taught you how to do your fractions, right? What do we use? DDD. You remember that, right? So we multiply this and that. What that's going to give us? 2 sine x cos squared x. We multiply the other way. It's minus sine x over cos 2x. Still leave it. I don't know what I'm going to do with it yet, but I'll see. What's common? Sine x. What do we have? 2 cos squared x. Now I know what to do with my cos 2x. Is that right? No, wait. Okay, I'll tell you what is missing. We did DD. We didn't finish the D. The denominator. Why did I clean the whole thing now? Okay. Yeah. Excuse me. Something was off somewhere. This one is going to be over the denominator. Cos what? X. It's diagonal denominator over another denominator. Can we simplify it to say divided by what? Cos 2x, just to make it simple to the eye. All right. I think that was what was off. But we're close already. What's common there? Sine x is common, right? What do we have? 2 cos x, no, 2 cos squared x minus 1. Is that fine? Over what? Cos x multiplied by 1 over cos 2x. Right? But what is 2 cos squared x minus 1? It's cos 2x already. So I didn't even need to change it. Sine x into cos 2x over cos x into cos 2x. What's your answer? Sine x over cos x, which is equal to what? Make sense? So when I'm not sure, I just hold on back a bit to see which one will work for me. Yes? Okay. Just quickly. All right. What are you canceling here? You cannot cancel. Minus. All right. Make sense, everybody? Okay. Last question for the exam season. Wait, I thought I had that question. Yeah. Wait. This one. This one, right? Okay, let's quickly run through. An infinite number of circles, each touching each other, are drawn from between C and O. All right, the centers of all the circles lie on the negative x-axis. The radius of the largest circle center at A is 4 units, okay? And the radius of each circle thereafter is halved, right? B is the largest of all the circles, okay? Is it making sense? As you move down, it's now halved. Show that OC is 16, so it's the length of the whole thing. And it's an infinite. They bring in number patterns, sum to infinity. But now, what would I do? Instead of using the diameter, instead of using the radius, can I use the diameter? Will it work? Because the first circle has a diameter of what? 8. The second one has what? A diameter of 4. So what's my ratio? 4 over 8, which is 1 over 2. So it's sum to what? Infinity. A over 1 minus r. 8 over 1 minus half. And that is what? 16 units. Lovely. Huh? The first thing I saw was that when I saw that infinite, I quickly thought about that. If BC is a tangent, where is BC? Oh, BC is a tangent to circle AB. So there's no BC here. Can we just try to... Right, if BC is a tangent to circle, write down the size of angle ABC, providing a reason. This is what? Radius. Is that fine? And this is what? Tangent. What is that? 90 degrees. What's the reason? Talk to me. What's the reason? All right. So angle ABC equals to what? 90 degrees. What's your reason? Tan perpendicular to what? Radius. 4.2.3. Hence, determine tan C. Tan C, which is actually gradient. They want us to find gradient. They want tan C. I don't know if you see where I'm going. That's what I'm thinking. They want us to find the gradient. However, because I know that tan C will be equal to gradient of what? No. Gradient of what? BC. Not BA. BC. Okay. The challenge now is, all right. Let's see something, guys. To get the gradient there, we have to get this angle, but we don't know that angle, though. But hold on. Got it. Got it. This whole length is 16. It means this thing is what? 12. OC is 16. OA is 4. Does that make sense? And this is the radius. This is also what? 4. Because we have a 90 degrees here, it's a right angle triangle. So katwa. That makes sense? Like I'm losing you. Did I lose you? Oratile? You look lost. Guys, is my measurement making sense to you? I have that. I have that. And I have this. This is 90 degrees, right? This is 4. What is this? 12. We are looking for that angle. I think we are done. If we are looking for this angle, let's call this theta. Oh, there's no need to call it theta. It's C. What is this? Opposite. Is that fine? And then, what's the other one? This one is there. Hypotenuse. So it depends on us what we want to do. We can decide to find the angle and then find the tan of it. Or we can use Pythagoras theorem to calculate this one first. It depends on us. Which one would be better? Calculate the angle first. Okay, it's fine. But we cannot use tan. We have to use what? Sine. So sine C is opposite over what? Hypotenuse. All right. So sine C equals to 1 over 3. What is C? It's the arc sine of 1 over 3. Now it means we can get tan C once you get that angle. Did it make sense? Yeah, all of the steps. You don't have to. Okay, what's the sine inverse of 1 over 3? Okay, no, don't have to have 19,47, right? But on your calculator, you say tan of that. You don't need to write the, just do this. Yeah, 10 answer would then be, because that's the value of C, right? Then, what is it giving you? 0.35 degrees. Let's check if it's going to be correct. Hold on. Since it looks very weird, right? Okay, let's check if it's going to be correct. We run out of time already. Let's use Pythagoras theorem to calculate the adjacent side, right? Since it's that. So what do we know? Hypotenuse. AC squared equals to what? AB squared plus, oh no, what am I saying? Yeah, plus BC squared. What is AC? 12 squared. What is AB? 4 squared. BC squared. Quickly, give me an answer. Are you guys calculating? What are you doing? Quickly. 144 minus 16. You should be on your toes now with the maths. 8 root of 2. Did you find the square root already? So BC is what? Now, what is tan C? Opposite over adjacent, right? What's our opposite? 4. What's our adjacent? 8 root 2. What's your answer? Can't you, where's your calculator? I need an angle. In terms of angle. What is 4 over 8 root of C? No, don't do tan inverse. You're not looking for C. What is 4 over 8 root of 2? Zero comma? So we're correct. That's it. Very small angle. So I've done it in 2 ways now. Done it in 2 ways. Hence, determine the what? Yeah, there's a hand up there. Quickly, very fast. My time is out now. Oh yeah, it's the gradient, not even an angle. So there's no degrees there. Yeah, we got the gradient. Tan C equals to M. Let me clean that. Thank you. Tan C equals to M. Determine the equation of what? BC. How do we get the equation of BC? We need a gradient and the coordinate of what? A point. Okay, do we have our gradient? Yes, our gradient is 0, what? 35. Is there a point that we know? What point? Huh? What is point C? 0 and 16. Oh, 16 and 0. So we're done. Thank you. Thank you. 16 and 0. Wow, what a lovely session I had today. So, gradient, equation of what? BC. Y equals to what? Mx plus C. What is our gradient? 0, 35. And which point are we using? Point C. X value is what? 16. And Y value is what? Negative 16. And Y value is what? 0. Makes sense, everybody? Okay, so 0. Do we really need... Oh, we want equation of BC, so we need it. 0 equals to what? 0, 35, negative 16 plus C. Somebody should be done with that answer. Sorry? I'm not hearing you, Hyde. 20? 28 over 5. All right. So what's our equation, therefore? Y equals to what? 0, 35x plus 28 over 5. Done. Did it make sense, guys? Make sense? All right. Huh? So, look at my time. What question is it? I've sent it, man. Which question? Huh? Let me see the question. But we did something like this yesterday, so you shouldn't be challenged with this. Guys, don't be scared. The reason you are giving me this one is because you are scared. Did you even do it? Did you try it? Thank you. Try it first. Send it on the group and try it. Nana, try it. It's a 2D and 3D. What are you supposed to do? Break the 3D into what? 2Ds. Yeah, so break, no matter what the question is, break it into what? 2Ds. Once you break it into 2Ds, you would see, am I using sine rule? Am I using cosine rule? It always works out. Don't let a question scare you. No, refuse to be scared. Send it on the group. Let everybody try. Is that okay? Send on the group. Let everybody try, and then we'll walk through. All right, guys. Have a lovely, lovely evening, and good luck with tomorrow. Let's discuss on the group if there are questions to ask. Okay.